Okay, welcome to everyone here to almost, I think that one of the latest talks in the day and for the conference here in J Champion. So we are going to attend to this amazing talk by Andres Almiray and Gunnar Morling about building modularized applications with Layrry, and they are going to explain how to to modularize these applications and if there are any similarities with other approaches. No jokes.
Nice one.
So here we have Gunnar Morling from Germany. Welcome, and he's the lead of the Deviation project and also a spec lead for the Vim validation spec. And it works as principal software engineer at Red Hat, obviously as a Java champion too. And Andres Almiray, welcome. And Andres is a Java Groovy developer, founder member of Griffon, also spec lead for the JSR 377. And also it's a Java champion, and he works as senior principal product manager at Oracle. So guys, the stage is yours.
All right. Thank you so much, Jonathan. Thank you for having us. And so for folks around the world, for us, it's pretty late in the day. So it's like 9 p.m. So definitely please do the best and come up with many questions. Let's make it interactive. We want to have a good and lively discussion. We will take questions during the talk, but also at the end, there should be time for it. And as Jonathan was saying, so this is about, the Java module system and Layrry. And now, I guess you have heard about the module system, and you might wonder, hey, isn't this the thing which, sure, it's used for modularizing the JDK, but then we don't see that much usage of it in, for applications itself or themselves. And this is exactly right, I would say. And this is what really is the motivation for doing this talk. So at some time, I thought, hey, what could we do to make this module system maybe more friendly to use, add some things for the developers so they would be very interested in using this also for modularizing their applications. And this is what led to the creation of this tool, Layrry, which is what we are going to talk about today. All right, so let's get into it. And I mean, Jonathan mentioned it already. So I work at Red Hat. I'm the lead there for the Deviation project, which is a tool for change data capture. So it gets change events out of a database and sends them to Apache Kafka. I've been working on Beam validation. And if you're curious what I'm up to, I would suggest you follow me on Twitter. And with that, I'm passing over to Andres.
So I'm Andres. And yes, I'm a senior principal product manager at Oracle, where I like to call myself a seasoned sorcerer. So I like to work with code, and I love open source. And that's one of the things that I do inside Oracle. I help teams get jump-started into open source. And I know that for some people, that's a little bit odd to put Oracle and open source in the same sentence, but that actually happens. If you browse to github.com/Oracle, you'll see more than 200 projects that Oracle has put out on open source completely for free. And you guys can go crazy with all that code. And so I stumbled with this project that Gunnar created early in 2019 about JPMS, and that's what we're going to see. So like Gunnar said, the JPMS stands for Java Platform Module System, also known as Project Jigsaw. You might have heard of this for many years ago. I think it started sometime after JDK 6 came out. And it took a while, and the whole idea for this project was to modularize the whole JVM so that it would be much easier to maintain. So break down the big monolith that is the JVM into smaller pieces, smaller chunks that will be much easier to manage. And while the architects and the people behind this process saw what they were doing, they also saw that, that these facilities, all the code that they were created in order to modularize the JVM, could also be applied or be applicable to applications, to the code that we as developers do in every single day. So that's how JPMS came out to be. It was introduced in Java 9, which was released a little bit more than 3 years ago. And well, the whole point of JPMS is that we are supposed to have much better encapsulation on how we design our stuff, how we expose public APIs, and how we hide away private or the implementation details and what have you. So we're supposed to have much better encapsulation. But as time passed by and people have jumped into JPMS, they have found a few things. So if you ask your colleagues, or maybe you have found some of these things to hold true. So JPMS only allows for one version of a module. The specification of the module version actually doesn't say anything about versions, other than you should not have a version number as part of your module name. So of course, that kind of creates a little bit of a conflict. What happens if, so right now you definitely have multiple versions of a particular library or dependency. And if so happens that you have multiple versions, at least 2 of them in the dependency graph, and those versions are incompatible, then you're bound to have a problem. So how can we avoid the same thing with modules? Well, right now, apparently there's no answer. JPMS doesn't allow you to add modules at runtime. You have to define a module descriptor at compile time. The compiler will check that all the requirements are met. This is something that you want, so early feedback. And once your application is assembled, you can run it, off you go. But if you want to make any modifications while the application is running, then apparently there's no option. You have to modularize all dependencies in order to benefit from JPMS. So there is this misconception that you have to have full module descriptions for all your dependencies in order to really have all the benefits of JPMS. That's kind of true. There are 2 other ways that you can have modules, but it's much better if you have full module descriptors. The sad reality is that if you browse through Maven Central, there are, of all the different artifacts that are hosted there, it's a good percentage of them that offer module descriptors, but certainly not all of them. It's so hard to map a dependency coordinate to a module dependency. Again, the modules only define the name. They do not define the means of how to store or retrieve safe modules. Right now, it's a sheer happenstance that we have 1 module per artifact or per jar. And the jar is the one that has the name, the group ID, the version, what we are known as the Maven coordinates. So how can we map one thing to the other? And finally, if the package is not exported, then you won't be able to see the behavior. Or if you have the same package split within different jars, that also a big no-no into JPMS. You cannot have a split package. So all this are issues that people see. I like to jump into JPMS, but I encounter one of these 2 issues and in my code base, and I don't know how to proceed, how to pass through these particular issues.
Yeah, and you mean the last one is in particular weird, right? Because even if you don't export stuff, so it's like a modular internal thing, still you would have this notion of split package conflict. And I feel this is something which shouldn't really happen, right?
Yes, exactly. So given all this, well, it so happens that as part of the API of the JPMS, what came out to be in JDK 9, there is one class, there is actually one facility called layers, which allow you to structure your modules in a hierarchy. And it's thanks to module layers that we can solve some of the issues that were presented in the previous slide. And here I know that Gunnar can do a much better job at presenting what actually module layers.
All right, so I mean, I just saw a nice tweet today that one of the strengths of the Java platform is Javadoc, and I would certainly agree. And so that's a nice coincidence because I have here the Javadoc of this module layer class. And I mean, you can read it for yourself, but really the key thing to understand is essentially it's like a function which allows you to define which class loader is used to load which modules in your modularized application. So you could think about it as a class loading toolkit, and you have different ways there, different options for loading multiple modules using the same loader, and so on. So that's really what module layers is about, and essentially it's like a loophole which allows you to address those things which we have been, seen on the slide before, where people perceive those issues like I can only have a single version of a module. Well, if I have different module layers and with different class loaders, well, then I can actually have multiple versions. And really, this, for instance, would allow an application server vendor to implement, the Jakarta EE application server model, for instance. But we also can make use of this in our own Layrry facility. So that's what it is about. And just to give you an understanding how you would interact with this Layers API. So, and you already can see from the slide, it's rather verbose. So essentially, you you define first of all a boot layer or a module layer, which should be like the source of everything. So this is this boot layer here, and this is the layer who loads the classes which have the modules which have been specified on the module path when starting this JVM. Then, well, you need to think about where do my modules come from. So this is what happens here with those paths there on lines 4 and 5. So I need to somehow get my jars. So there's no notion of provisioning this, getting this from a remote Maven repo, for instance. Instead, I need to think about how do I obtain those files, and then I can provide them on the local file system, and I can set up this module finder, which exposes them to this Layers API. I need to do this configuration. I need to create this configuration. This is about, well, this setting up the module graph, given a set of root modules, which would be those foo and greeter modules here. And then I have this configuration. Finally, I can take my parent layer, this boot layer, and I can define my new module layer called foo layer in this example. And here I'm using this method define modules with one loader. There would be other methods for using multiple loaders, but this is what I'm doing here. And then finally, I have created this module layer instance. And as you can see, it's quite complex, but it's of course powerful. And I mean, somebody implementing an application server, they would need all this flexibility, I guess. But for our purposes, we might be able to make use of this and provide a simpler and easier to use experience based on top of this API. And this is really what Layrry actually is about. And now, why would you use this? To give you one example, so let's say I have this sort of application here where I have an app module. This app module refers to two other modules, foo and bar. And now they have transitive dependencies. So foo as well as bar, they both depend on this greeter module. They also depend on the Log4j API, but they both depend on this greeter module, and they depend on different versions. So foo depends on the greeter 1, and bar depends on greeter 2. And now, as said before, well, if all this were loaded via a single flat module path, well, I would have an issue. I could only essentially apply one version. And well, now, of course, those things are like incompatible versions, right? So hopefully the authors use semantic versioning there. And really, we would like to use those two different versions. Maybe there's some API change there, and the bar module only can work with greeter 2.0, and foo only can work with greeter 1.0. And by loading those components into different layers, we can enable this kind of usage. So let's see how this would look like with Layrry. And there's different ways of how you could use this. And one would be using this API. And it's a basic Fluent API. And I think it's pretty self-explanatory what's going on here. So first of all, you define this log layer. And there I load my Log4j stuff, Log4j API, Log4j core. I have another layer called foo, which uses this log layer as a parent and which adds two modules, greeter and foo. And now you might wonder, where do those modules come from? And well, if you have been using Maven before, you see those are Maven artifact coordinates, like group ID, artifact ID, and version. And underneath, Layrry will actually use the Maven Ether API for obtaining those jars, for resolving the versions, obtaining those jars from Maven Central or other remote repositories which you have configured. And this is how we get those jars, those modules to our local machine without having to download them. So I can keep going. I create this foo layer. I create this bar layer, which again uses the log layer as its parent. And now this has a different version of the greeter module, so greeter 2. And lastly, I have this app layer, which depends on both foo and bar, which also adds like another app module. And finally, I can run this thing. And there I specify essentially the main class and some parameters. And now this could use those two modules, foo and bar, and their dependencies, the greeter dependencies in their different versions. And this works as long as those conflicting versions are not shared across API boundaries. So if at some point, this app module or this app layer would receive a greeter class instance in the two different versions, well, then we would run into issues. But typically, those transitive dependencies, they are like used internally, and then we are perfectly fine with this kind of isolation. And really, just to make this very clear, all the heavy lifting here, this is done by the Java module system and this Layers API. So like 90%, it's like this iceberg, 90% is done by the module system, and really Layrry just adds a small shim of making this a bit nicer to use, doing some sort of opinionated choices. So there is one class loader, for instance, per layer. So this is just something which we define. And we add this notion of provisioning. And then this gives you this, well, I would say pretty nice developer experience. And just to add one more thing, so as I said, there's this API, which we have seen. So this is a fluent API, which you would use in your Java application if you wanted to bootstrap something programmatically. But then there's also a ready-made launcher. So oftentimes you don't even need to implement this Java class for launching this. You also can use just this ready-made launcher utility, which comes with Layrry. And now this is configured using a YAML file or using a TOML file. And there could be other options, really. But the idea there is now this is a descriptive way for configuring this, right? So it's the same application we have seen before with those layers, log, foo, bar, and app, and the main class, but I didn't even have to implement any code here for this launcher. I just can launch or call this Layrry Launcher facility. I point it to my layers configuration, and then this will start up this application. And I have now, well, not a flat module path as I would have it when I were running the plain Java utility, but I really have this hierarchy of layers, which allows me to do those nice things like loading multiple versions of one class. And now there's quite a few more options to this launcher and the configuration, and Andres is going to talk a bit more about those things.
Right. So if you remember, one of the reasons why Layrry exists is so they can resolve modules based on Maven coordinates. And we typically configure these Maven coordinates in a build file, whether it's Maven, Gradle, or something else. So you may thinking that there's going to be a bit of repetition between what is specified in a build file and what's going to be specified in an external configuration file, whether it's YAML or TOML. And for this reason, in order to reduce this duplication, we allow parameterization of external configuration files, regardless of its YAML or TOML. Here in what we're looking here at the slide, it's another completely different application. As a matter of fact, a JavaFX application for which we decided to parameterize a few things. The version number of a particular dependency and the classifier for the JavaFX dependencies. Because if you know JavaFX, the jars for, let's say, for base and controls and graphics, FXML, all these dependencies actually require platform-specific support for certain behavior. So there's bound to be a base jar that works for Windows, for one for macOS, and another for Linux, for all the supported platforms of JavaFX. So if we want to have an application configured through external means that can run on all the supported platforms, then we also need to abstract that classifier. The name, OS detected JFX name, it's one of those additional properties that the Layrry Launcher automatically detects upon bootstrapping the application, and will use that value. Well, actually, we'll use that as a placeholder and put the right value for you. You can also supply additional properties that can be mixed in by the launcher, such as the version numbers that you see in the second screen there. So we have the version number for our project, the version number for JavaFX, the TilesFX, and Layrry, which are the additional dependencies. So the additional thing that we have to do when launching through the command line is, besides defining the layers config file, we also define what is the file for the properties. And once you do, then the application will just work.
Right, and I mean, you would probably be able to generate this versions file out of your build process, right? So you maybe you have a Maven build where you have to find those versions. You could generate this versions properties file automatically, so you wouldn't have any sort of redundancies.
Certainly, you can use the Maven resources plugin and the resources plugin from Gradle if you use the other tool to help you generate these files and have the prepared numbers. Yes. Here's another way that you can use to launch a Layrry application. There is this tool you might have heard about. It's called JBank, which allows you to launch single source files with dependencies. But, well, it also adds more capabilities. It grew beyond that. It was JEP 330. And the thing is that JBank has a feature called catalogs. And a catalog is nothing more than a set of files in a specific GitHub repository that you can control and follow a naming convention. We have one for Layrry, which if you have JBank installed in your system, just point it to the Layrry catalog and pass the parameters for the launcher. And what's going to happen is that JBank is going to download the Layrry Launcher jar and all the dependencies required to run Layrry, and then proceed to launch your application. There is another feature that was added recently, and so far we have said that Layrry will resolve the dependencies from a remote Maven repository. It can actually resolve from Maven local, but these are seen as a standard Maven repositories. So you would need network access for Maven remote, or you would need file access to a particular Maven local repository. What if you wanted to do the opposite? If you wanted to package and to close down on the locations where the dependencies can be hosted? What if you were to package all the dependencies, all the jars into one directory and have Layrry look at that directory? And that's exactly what the local repositories feature is supposed to do. You can have two different layouts. It's called the flat layout or the default layout. And you can configure this using the API, the YAML config file, or the toml config file. Here we're showing the example for the YAML config file, where we say that we're going to have one local repository, one additional local repository, whose name is repo name. It could be anything you want to. The layout is flat, which means all the jars will be on the same directory, one next to the other. And we also pass the path to this particular repository, which may be absolute or it may be local, relative. And if it's relative, it's the base here for this repository will be the location of the layers config file. And the next slide shows you how the flat repository looks like, which is nothing more than a collection of jars in a single directory. And the next slide shows you the default repository, which is kind of what the Maven local repository looks like, but without POM files. And the advantage of the default layout is that if your artifacts rely on classifiers, it's much easier to determine what is a classifier and what is part of a version. Of course, we have ways to know this with flat layout, but it's much easier if it were to be the default. Regardless of your choice, Layrry will be able to launch an application with all dependencies located in a particular directory. And the next one, which is really exciting, is remote layers configuration. So far, we have seen that we can resolve external configuration that is available local to your computer. We may be able to resolve dependencies that are local to your computer or remote. So the missing step was, what if we wanted to resolve external configuration that is available on a remote server? And that's exactly what this allows us to do. The layers configuration file, YAML, toml, or any other supported format, you can put it on an HTTP server or HTTPS, whatever it is. You can also put the version properties, if you want to, into a remote server, and then just grab those two URLs, pass it to the layers config parameter and to the properties parameter in the launcher, and you're good to go. You can mix in local repositories. If you want to resolve dependencies remote or locally, that's fine. And you can also mix in plugins, which is a feature we're going to see in just a moment. But in this case, plugins still have to be local to the machine that is running the application. You cannot have remote plugins yet. So what is this thing about plugins, Gunnar?
Right, so let's talk a bit about that. And well, so this layers concept, this allows us to organize our application into multiple, well, self-independent units. And you could maybe think about this sort of maybe like a microservices-like isolation within one monolithic application, if you will. But all this is, so far what we have seen is defined statically. So you know which are my layers if you assemble this application, and then it will be loaded based on that. But then there's also this case where you might not know which particular implementations of specific service interfaces exist in your application. So let's say you define some sort of service interface used by the service loader, and now there could be multiple implementations which are contributed to the service loader API at when the application gets actually started. So your application itself just knows about the service interface, but then there could be multiple implementations provided via different layers, which again would then be isolated. So now this could happen at, let's call it assemble time, so when this thing gets put together or when you start it up. But then you also could have a use case where you actually want to add or remove such sort of plugins dynamically at runtime. So your application is running and you would like to add a functionality, or you would like to update it, you would like to remove something. And this also gets possible by means of this interface plugin lifecycle listener. But actually, let's first take a step back and just quickly reflect, when would we need this? And I would argue you would need this sort of dynamic plugin functionality, mostly in client-side applications, something like a Swing or JavaFX, some sort of where there's a user interface. So if you want to install a new plugin into your IDE or your editor or your browser, well, you don't want to restart that, right? You want just to be able to add a plugin or update a plugin while this thing is running and then be able to use this. So there you definitely have this need. I would say you don't have it as much on the backend side of things. So if you have like your microservices or your monolithic application, then I would argue you don't really need this sort of dynamic update functionality, well, because typically you would have multiple instances of application behind some sort of load balancer, and you just could take them down one by one, put in a new version, and restart them again. The load balancer would make this transparent to the user. So I'm just adding this, so you should, not just cliently use this concept, but really, I mean, it adds also complexity, as we will see. But there is cases like clients where you definitely do benefit from it, and this is why this is supported. Now there's this interface, and it's really simple. It's just two methods, plugin added, plugin removed, which are callback methods, which are invoked, well, if a plugin layer gets added or a plugin layer gets removed. And what is a plugin? Well, it's just a module layer, which essentially has a name, and that's about it. And the directory where to get the modules from. And this is what this plugin descriptor is giving us, or the list of modules, you could say. And now we can react to this and implement this kind of functionality. Now, how does this look like? Well, typically, you would, again, use the service loader. So I should say the plugin lifecycle listener, this is loaded via the service loader itself. So if you want to react to those lifecycle events, you would create a service implementation of this plugin lifecycle listener contract. And then what you typically would do is, again, you would use the service loader yourself to look for implementations or for service instances of application-specific service contracts. So here in this case, I have just this my service interface, and this is now a domain or an application-specific service contract, which, I don't know, contributes some sort of UI functionality, contributes some resource bundle, whatever the service does. So it's specific to my application, and this is what I'm looking up here. And now I just need to be aware of one, well, I would say particular thing there. And this is, I get, when I load my services like that, I get all implementations which either exist in this module layer, which just got added, or in any kind of parent layer. So if I have like a layers hierarchy, I would also receive here service implementations which are added by parent layers. Whereas typically here in this plugin scenario, I just would like to add those or to consume those service implementations which are contributed by this particular layer which just got added. So that's why I need to do this kind of comparison here. I kind of wish this would be a bit better supported in the service loader API, but well, for now, this is what we have to do. And to make this a bit more tangible, Andres now has a really cool demo which shows you how to use those things in action with JavaFX.
Before we jump into the demo, there is a question on if these layers, can they be shared or inherited between projects? Actually, not really. So either if it's with the API or with external configuration files, you could think that these would be additional resources that you can package in a jar and then ship it in your jar, and then have another application, which is the one that consumes these jars and modules to assemble everything together. Well, not really. It is the job of the final consumer to compose all the different modules in a way that makes sense for that consumer or the application. It is not the job or the responsibility of a dependency right now to say, this is how I want my consumers to see me, or how I want these consumers to consume me. We could be probably thinking in the future if it makes sense to have some sort of reusable sub-layer configuration, but it's nothing that is currently supported.
Yes, but I think actually it's an interesting point. So you could think about having some sort of means of, defining like a reusable layer which contains of like those 5 modules in a particular version, and somehow this would be a named defined artifact which Layrry could resolve. So it's an interesting thought for sure.
Right, that's an interesting one. Okay, so I'm going to launch a JavaFX application that is fully available to everybody. And I will post the link so that you can see it. That's actually going to appear in the slides. Now, I will be running Layrry on the command line, and I created an alias so that I don't see a full path of everything that I have. So if I run Layrry right here, this actually resolves to invoking the Layrry Launcher through the binary distribution. Now, the JavaFX application that I have here is quite simple. What it's going to do is display a small window, and in this window, there will be visual elements that will be added or removed depending on dynamic plugins. And I believe the first the state is to have no plugins. So if I look at the current staging directory, here I can see that I have a layers config file, the layers toml file. I have one plugin that is one of those dynamic plugins already installed in this directory. I have several options with different formats to copy those plugins into the plugin directory. And I also have the flat dir repository. So I'm going to launch Layrry twice. Once resolving the dependencies through Maven local and Maven central, and another one completely separated from Maven, and it's going to be just local dependencies. And finally, there's the versions property you can see at the bottom. And if we had a look at how these layers files look like, let's look at first this one. This is exactly the same that we saw in the slides before. We have a layer for the JavaFX artifacts that we need. There's the classifier that is going to resolve to my platform, which in this case is Mac, and the JavaFX version. And then the additional layers, the core that contains our actual application, and the layer for the dynamic plugins. The name plugins could be anything you want to. I decided to go with plugins. The name of the directory is also a name that you choose. I decided also to go with plugins because why not? And then the main class is right there. And if I show you the versions properties, those add the numbers that will be used in order to mix in with the layer configuration file. Okay, so what I'm going to do now is instruct Layrry to learn to run the configuration file from that location, layers toml, and I'm also going to pass the properties so that it knows what to do, staging and then versions properties, and launch it in the background. And you see these warnings is because it's trying to download metadata from an artifact located in Maven Central that does not exist. That tells me that it's actually trying to connect to Maven Central. Good. You can tell by the current time that this is live because we're located in the Central Europe right now. So that's when we're streaming from, Germany and Switzerland. And what I'm going to do externally, I'm going to copy some of those plugins that are outside of my application into the directory that Layrry is watching. And so I do that by saying copy from staging plugins prepare, and let's copy this one as a zip file into the plugins directory. And once I do that, notice that a new visual element appears. It's animated as well. Now I'm going to copy from plugins prepare another plugin, the Sparkline, and I'm going to copy the tar.gz and then put it into the plugins directory. I now have a third element right there. I can remove one of those if I want to. Let's remove the one in the middle. Let's remove from plugins, tile gauge like that, and it's gone. Of course, I'm doing external modifications, but you could imagine that if you had a menu on your application, you could download from Maven or download from any server that you have access to any of these plugins, put it in the right directory, and Layrry will pick it up. Now I'm going to showcase the other way, which is running from local repositories only. So that is Layrry layers config, and this time we're going to pass in, oh, actually I should show you how that looks like, the layers local tunnel. The only thing that we have is it says we don't want any remote resolution. If anything has to be local, and it's going to be in a flat directory, and that directory, the path is this particular configuration, which actually resolves to what is inside the staging directory that I showed you earlier. So now I can go back and say Layrry layers.
We should have some bash completion.
Yeah, I know. Sometimes I'm lazy, sometimes I'm not so lazy. So that's the only difference is that layers file. Then we say properties, staging versions properties. And the application is launching. There we have it. And notice that there is no additional printout that trying to resolve dependencies from Maven Central. So now I can, I can send it to the background, and I can copy from staging plugins prepare the last thing that we had, which was the gauge again. Let's copy now the jar into the staging plugins, and it's working again. So how this thing work? Using the lifecycle listener that we saw earlier. Here is a particular implementation for that lifecycle listener. This is the Layrry the type. And this is the custom implementation that is specific to this application. So we need to implement two methods, plugin added and plugin removed. In the plugin added, like Gunnar said, we're going to use the service loader to locate instances of some application-specific class. In this case, it's called type plugin. If we navigate to that type, it is application-specific, and it does something. It has an ID, and it knows how to register itself with the UI context. This is a class that knows where to put the things, the visual elements. So we'll be back to our plugin lifecycle listener. And once it has figured out what are the list of plugins that it needs to handle, it goes to another application class called plugin registry. And this is the one that knows, okay, now I have a plugin. I need to configure that and then put it into the visual element. And when a plugin gets removed, when a jar, a zip, or tar file gets deleted, then this method will be invoked. And then the plugin registry is also getting invoked. And once we do, this is going to unregister all the plugins. And if we want to drill down into the specific implementation, you will see in this registry class, what is actually happened is that at some point, this class that contains the UI context will know how to handle that plugin registration. At this point is where the UI gets created, the actual clock element or the gauge or the sparkline, and then attached to that visual element. And when we unregister, we simply remove that thing and you're done. And we continue, if we want to, we can continue to drill down and go into very application-specific code. But I mean, that's like an exercise that you may want to do if you browse the code. The important bit, again, is that we create an instance of this thing, and we register it with our module descriptor as a service. Like this. Once we do this, then Layrry will detect the lifecycle listener, register at the appropriate time, and whenever a plugin is added or removed, then our implementation will be in charge. So we got a question. What is the advantage of using Layrry in comparison with OSGI?
So, yeah, I mean, of course, that's the first question. It's like a lore. If you do a talk about Layrry, the first question is, how does it compare to OSGI? And I would say, it's just on a very different level in terms of aspiration and complexity. I mean, if you have been working with OSGI, you will know it's a spec of hundreds of pages, which add tons of functionality. They feel like their own services concept and tons of stuff. And really, Layrry is just much, much less aspirational. Really, the idea is to give you some means of just using what's there in the JDK, module layers, service loaders, those kind of things, modules, and use those built-in artifacts to create modularized applications. And it solves those issues like being able to use multiple versions of one dependency, maybe the sort of simple dynamism which we have seen here. And that's really, that's it, right? And well, it deals with provisioning, of course, but really the idea is to give you something which I would say lets you address many of those use cases you would have around modules, and just make them work for you based on what's there in the JDK.
Right. You can see that there's certainly some overlap in the features provided by Layrry and OSGI. And OSGI has more than a decade in the open, and there are so many different APIs that are related to OSGI. There's integration with different module systems as well, different dependency containers, and so many other things, because it has had so much time to grow and to add features on top of one another. Whereas Layrry is a project that is close to be a 1 year old, this much, and we are coming up with what is the minimum set of features that we think are good enough to provide what we want to do, which is resolve conflicting modules with different versions, or dynamic plugins, which certainly look a lot like what OSGI offers with the activation and the passivation. But yeah, I mean, you can use one or the other if you want to. I mean, it's up to you, depending if the features provided by one project or one implementation of that specification actually does the work for you.
I mean, one thing also to keep in mind is I would argue that Layrry is much more approachable because, well, again, if you've tried OSGI, you will know, well, you need to have all the module data for all your bundles, right? And if you don't have it, well, it's sort of a problem. Whereas here, you don't really need this. So I don't think the Java extras in this demo, they even have module descriptors. So really, this is more isolation, cluster isolation on a coarse-grained level, right? So in OSGI, you would have like one cluster essentially per bundle, whereas here we can do this more coarse-grained, and we just can think about isolation in terms of those, well, layers, domains of our application. We don't need to think about isolation in terms of each and every module, strictly speaking. And I feel this makes this just a bit easier to adopt and just use this. And many things I felt just work in this kind of setup because you just add as much isolation as you really need and not isolation per module if that's not what you need.
Right, exactly. So this being said, Layrry is easier to get started, it's more approachable, and because it's a smaller surface in terms of features. But if there were a feature that OSGI provides or something else, if you feel like there is a feature that Layrry will benefit from, we certainly encourage you to reach out to us and fill out a ticket on our on our GitHub repository and let us know, engage in a conversation. Perhaps there's something that can be done. Maybe we add the feature. Maybe there's something else that needs to be added in order for Layrry to support that particular use case. I mean, we don't know until we try, right? So moving on, let me put the slides somewhere. Here we go. Let's present this. All right. And actually, this one is for you, Gunnar, but let me set the stage. When we build this JavaFX application, because we're doing class loading and unloading at runtime, there is the highly potential problem of having a memory leak. And for this particular JavaFX application, we did have a memory leak. But thanks to some of the things that Layrry provides, we were able to find out what was going on. And Gunnar is the one that did pretty much of the whole work for investigating what was going wrong with this particular application.
Right, and I mean, the thing is, so, well, where you have control in Java over loading classes, you don't really have control over unloading classes, right? So there's no API in the JVM which you could call to unload a particular class. Instead, what happens is, well, the class object will, or the class really will become subject to the garbage collector once all references to this class have been collected before. And now this only is the case if all classes from the same class loader are eligible for garbage collection. So this means as soon as there's one class which cannot be collected because, well, there's still some reference to it, no class of this same class loader can be collected. This is what we mean if we speak about a class loader leak. And now the problem is, if we remove such a plugin like the Gauge plugin layer, well, all its classes should become available for garbage collection, hopefully. Now the thing is, if we have code in still running layers which hold on to a reference to one of those classes, then this couldn't happen. So we've seen this plugin registry class in the demo, and now this runs in this base layer of this application. And now if we were to implement this incorrectly, we would keep references to the plugin classes after they have been removed. Well, then the classes would still remain, and we would have this sort of class loader leak. And so that's one situation where you could have a class loader leak. So like a reference in a layer which still is running, but there could be other things like maybe you started a thread from within code of this layer, and now you remove this, you forget to stop this thread. Well, it still would be running, and you would again have a class loader leak. There's a few other situations like you registered a shutdown hook and you forget to unregister this. And well, again, you would have this sort of class loader leak. And now, well, to understand what's going on, well, first of all, you can enable the class loader logging, but also you can use tools like the flight recorder and mission control. And this is actually what we did here, and which Layrry facilitates. So Layrry produces specific JFR events in certain events or in certain points in time of the lifecycle. So right now we just expose events when a plugin layer gets added and when a plugin layer gets removed, but certainly we will have more custom JFR events in Layrry. And now this is, of course, very interesting because you can do this kind of JFR recording with the JDK flight recorder. And here, for instance, you would see, okay, I have those events where my plugin layers were added and where my plugin layers were removed. And now what JFR and mission control also tells you is when classes are loaded and classes are unloaded. So now what you would expect is if you remove such a plugin layer and you see this plugin removed event from Layrry, you also would expect that sometime thereafter those classes get unloaded. This is what we actually see here. You see those class unloading events. So first of all, you need to make sure this is enabled in your flight recording. I believe by default, well, it depends on the profile you use. So you need to make sure that class unloading, class loading, that this information is tracked, so you would see it. And also, it depends a bit on the garbage collector configuration when it would actually unload classes. So this might happen only if there's like a major GC coming in, or well, if you have like the new neural collectors like CGZ or Shenandoah, but also G1 can do it, then you would see this pretty eagerly happening. So you would expect to see those events, but now let's assume we don't see them. So we see plugin removed events, but we don't see those class unloading events. So this indicates, well, something might be wrong, and we can see it on the next slide too. Because here I'm taking a look into a heap dump here, and now this looks pretty suspicious because I have multiple instances of this clock tile plugin class, which are apparently associated to different class loaders. And this is pretty suspicious, right? The same class being loaded multiple times, this pretty much is an indicator that something went wrong. And I need to look into what's going on here. And by the way, this is using the Eclipse memory analyzer tool, which I can highly recommend for this kind of purpose, because if we go to the next slide, we also will see, we will be able to understand how those references this came to be. So first of all, we saw, okay, there's multiple instances of this class hanging around, so that's weird. But we also can see where this is coming from. It tells us what is the path, the shortest path to what's called the GC root. And now here in this case, I was creating a basic example, and really, I have this class there. It's suspiciously named leaking plugins, and this is exactly this case where which I mentioned. So now this plugin registry, it just was implemented incorrectly. Classes or plugin types were added to this plugin registry, but then upon plugin removal, we forgot to remove those classes, and this is how we had how such a class loader leak could happen. The actual case which we had was a bit different. There it actually was the thread which starts the animation of the those Spark lines and so on. So just from those tiles to give you some random looks, and this thread which we didn't know about initially, this was causing the class loader leak. But you would find out about this pretty soon. All right, so that's class unloading. You really need to be careful there. And that's pretty much it. We got a few more minutes, and we should talk a bit about what's coming up on the agenda for Layrry. And I believe, Andres, you wanted to mention a few things there, right?
Right. So when I run the demo, I run it using the binary distribution instead of running directly from the jar. One of the things that we want to do is make sure that you also have access to that binary distribution. It's just like a typical Linux distribution with binary and libs. And we will post it on our GitHub release page, and we'll probably make it available also through Homebrew, SDK Man, or any other package manager that makes sense. If we are missing someone, please let us know if you want to use it with some other package manager. Maybe it's a Scoop, Chocolatey, Snap, Winged. Just let us know. There another thing that we may be looking into the future is this ability to have self-contained distributions. And this is something that may or may not allow you to download a specific Java runtime before running the application, or you may need to have a specific runtime available in your machine before running the Layrry powered application. This Java runtime may be a standard JDK or standard Java ARE from any vendor, or it could also be a JLink image that provides the very basics, or even some of the other additional modules that Layrry Launcher requires. This kind of self-contained distribution, we call it a capsule. You can think of it as a zip file that contains all the dependencies in a local repository, the launcher, the external configuration file, and a properties file. And it could be a self-extracting zip file and then executable, so you only need to double-click on it or just type it out in the command line, or maybe it's a two-step process. We will see, but that's something that will allow you to have much better control on how you want to package and deploy applications. There was another idea there in order to keep reducing the duplication within what is a build file and the layers config file. What if we were able to derive the layer configuration based on a series of POM XML files? That's an option that we're currently investigating. We still have no clear answer on how to make it happen, but that's definitely one of the things that we'll like to look at. We will also, as Gunnar said, we would like to provide additional JFR events. So as much information and analytics and metrics that we can provide into the inner workings of Layrry much better in order to detect any potential problems. And then lastly, there is this idea about the programmatic plugin API that right now your application is completely unaware of if it's running with Layrry or not, even if you only expose your own plugins. But what if you wanted from within your application to be able to reach out into the layers or into the inner workings of what the launcher did for you? So this is kind of the idea what we're looking at right now. We still have no clear path on how to solve this. We are just throwing ideas out there, but we think that we know where we want to go with this. And lastly, well, if there, again, as I mentioned earlier, if there's a feature that you see it might make sense to mix in with what we currently offer with Layrry, please let us know. And we'll be very happy to discuss and see where we can take this. We have some resources. The homepage of the whole project is located right there on GitHub. The organization name is Moditech, and the name of the project is Layrry. The JavaFX application that you saw today, plus the example earlier of conflicting modules, plus another example that uses dynamic plugins in the context of a Vertex application, so serverless, they are available in this Layrry Examples directory. All the code is freely available for you to study. The JavaFX example, by the way, has both Maven and Gradle builds, so you can study how to package and deploy these kind of applications with your favorite build tool. We also have a couple of blog entries on what Layrry is and what you saw today. So the first blog entry by Gunnar is pretty much the hello world, this is Layrry, why I did Layrry, why I'm spending my free time on Layrry, why I think that Layrry is a good idea. The second blog post is showcasing part of the plugin architectures that we saw on the demo today. And the third blog post is the full investigation on the memory leak that we had in the JavaFX application and how Gunnar made use of the tools that he gave you a quick tour today. And this is how the things that you could also use in order to detect all kinds of problems in your own applications, regardless if they are Layrry related or not, as long as you have Java flight recorded events enabled for your Java runtime.
And I believe you got a blog post in the pipeline about the JavaFX example, right?
I still have a blog post coming up on explaining how you can properly do the plugin with plugin setup with the JavaFX. Yes, and is hoping that I can get it finished quite soon, because where we were missing a few things we actually changed the format of how we handle plugins, which is what you saw today. And now that we have this is pretty much done, then I can certainly go in and write that blog entry. Yes. We have a question from Dr. Lofi Devanto. It says, okay, this is nice. Would it not be better to integrate the module version stuff into the Java module system directly? Perhaps, and I'm pretty sure that this topic was discussed extensively within the Java architects and everybody that was in the committee that wrote the specification for JPMS. And there's pretty sure a very good reason why they didn't. Now, we're lucky that we have access to the module layer type, which allow us as outsider of the JDK or the Java standard library, the JLS, to come up with a library like Layrry, to play around to see if that particular feature can be provided. And as you see, you can have two flavors. You can have remote dependencies and local dependencies. Local dependencies, that's kind of easy. It's just files. And that could be provided by a JDK. But for remote resolution, you are already marrying or attaching yourself to Maven coordinates. And so far, not a single JDK vendor has done something like this. Now, if Maven coordinates were to become a standard and that were to be embraced by the JDK, I guess, sure, why not? But that's not currently the case. So playing around with these external concerns, things that are not JS standards or the specifications, makes sense to do it on the outside of the JDK.
Yeah, I mean, it's the version format, but also it's things like the resolution algorithm, right? So, for instance, if you think about Gradle and Maven, and you were to obtain the same artifact, which have, like, let's say, a rather complex tree of transitive dependencies, you would end up with potentially with slightly different trees being resolved because different rules apply. And yep. I'm not so sure whether it makes sense to encode all this into the JDK. But that being said, I was also thinking this, I used to think like that, but then I felt, well, we can just handle this in this layer on top of it, and it works fine. So I feel it's not a huge issue, actually, as we may have perceived it in the past.
Right. So right now it makes sense for Layrry to continue being a completely separate open source project, and we are currently not thinking any sort of standardization because the project is quite new. If this project grows to a point where it's quite enjoyable and used by a lot of people, we might be thinking, what if it becomes some sort of a standard through maybe the JCP as a standalone JSR? And I'm pretty sure that Gunnar had never heard about this. I'm just throwing it right now live because, again, the project is still in the early stages. It's young. There's no point in standardizing yet. But even if we wanted to, we still have the choice. It could become a standard, but it does not have yet to be provided as part of the JDK itself. It could be a standalone standard.
Right, definitely, yeah. But I mean, we also want to learn from the past, right? And don't standardize stuff prematurely and so on. So right now, it is always an exploration. We want to see how people think about it. Is it useful? What kind of use cases would people, use this to implement? And then at a later point in time, you might want to think about it.
Right.
So apparently there are no more questions.
So I'm going to put again in the links to the project, and you can navigate to the issue tracker in case that you find any problems or you have ideas about features or just you have any questions regarding Layrry, let us know. You also have access to our Twitter handles. We're quite active on Twitter, where you can reach us out on different platforms and mediums. So we're always happy to talk open source.
Yeah. And I think exactly that's exactly the point I want to make. I'm not sure whether we mentioned it. So all this Apache v2 licensed. So it's really fully open source. It's not source available. It's fully open source, and this means people can contribute. They will keep their copyright and stuff like this. So it's hopefully there could be a vibrant community around it.
Yep.
Okay. So yeah, thank you very much for this amazing presentation, and for sure people will see modularity from a different perspective, because I remember when I started using OSGI and the learning curve was not apparently as easy as it seems with Layrry, and the results, I assume that in most of the cases are enough. So probably it's a good option. Thank you very much for everyone being here. I hope to pronounce it well. Gute Nacht.
Very well, yeah.
Buenas noches, Andrés.
Buenas noches.
Good night for everyone, or good day part wherever you are. So hope to see you again in the next editions of J Champions. Thank you very much, and hope you enjoyed.
Thank you so much for having us.
Thank you, everybody. Thank you, Jonathan. Thank you, Gunnar.
Bye.
Bye.